Thank you very much for coming. My name is Razan Polutnik and I'm coming from LX Now company. We are producers of LX8000, LX9000 systems, and I will give you a slight preview what we are doing now, what we are going to do in a near future, and how maybe the gliding instruments will look in a little bit more distant future. So let's first have a look at variometer, which I believe is the most important unit for a glider pilot. Here on the picture you are going to see our V9 variometer, which came in 57mm form. You have a mechanical needle and a bright screen. However, the biggest value of this variometer is hidden behind the screen. Inside the screen, inside the variometer, they integrated a bunch of sensors. So we have integrated 2 pressure sensors. We have a 3-dimensional accelerometer, and we have a 3-dimensional gyroscopes. So one would ask how all these things help making a variometer better. So unfortunately we have to take a look a little bit at variometer calculation. We are very lucky that our company is situated in tower building, so we have an escalator, and we can move up and down for the whole day in order to perform all the calculations. So let's first look at ordinary variometer as it used to be in the past, where we calculate the vertical speed only with the pressure sensor. So the calculation is very straightforward. You just measure the altitude and you measure altitude in next time moment, divide that by time, and what you get is vertical speed. Here I will explain that graph a little bit. What you see here, just let me see if the pointer is working. Oh, okay, it's working. So this is one of the experiments we are doing in our tower building. So that's where we enter the elevator, then we drive with the elevator all the way down to the ground floor. So here is acceleration, then a stable run to the ground floor. This is the stopping phase. Now we are in a ground floor, not moving, and then we go back into the top floor, accelerating, steady speed going down. The blue line at the back is the response of, let's say, ordinary variometer using the filter as it is. The red line in the front is variometer calculation using just pressure sensor but not filtered. So you see there is plenty of noise on it, which make us glider pilots very nervous. So we try for the second approach, using accelerometers. Using accelerometers is exactly that what your backside of the body is doing. So when you hit a thermal, you feel that on your backside. So the calculation is very simple. So you just take acceleration, multiply it with the time. So basically it means integrate it, and you get a vertical speed. So the first experiment is very easy to done also on a table. So all you need to do is just to blow into the pressure tube of the variometer, and you can get such a result. But the second experiment is much more different, because you have to move your variometer. So again, we have here our test bed steady phase, accelerating. So this is the constant speed, down, deaccelerating, ground floor, accelerating, steady speed, deaccelerating. And you see that using just acceleration, actually what you are getting is less noisy signal, but the problem is that it is sorry. But the problem is that you get that you don't get a stable zero. So you see when actually there was a stable, a constant speed, you don't see a constant speed here, and you don't see a stable zero here. That's because that when you are integrating the acceleration, you are accumulating error, and you see this drift because of that. So using modern fusion algorithms, which takes all these sensors into account and Kalman filtering technique, we get such a result. So again, the blue line is a normal standard pressure varying meter, and the red line is such a modern, let's say, variometer system. So what we see here, just ignore this at the beginning, it is not important. So you see, we have a very steady signal when we are standing still, very fast acceleration, steady signal, deacceleration, steady signal, and again upstairs. And what is very important is following. So I would like that you compare this signal with this signal, and you see the red line and the blue line, and you see that the response time of such a variometer is much faster than compared to the ordinary pressure sensor variometer. This difference here is roughly about 1.7 seconds. So it means our variometer indicates much faster than ordinary variometer. So I was very happy when we saw those results. I went flying, and unfortunately, when I was flying, I was not so happy about results, because I didn't get better thermals or nothing like that. I still believe that it is the best variometer on the market, but when you are flying, the story is a little bit different, and that reminds me to Klaus Ullmann saying once to audience, like we are here, someone from audience asked him what is the best variometer on the market, and because he was flying with our variometers, I was pretty sure that he is going to say Elixna variometers are the best, but he didn't reply like that. He said that it is completely unimportant what kind of variometer you are using. The most important is that you are used to it. So what I'm adding now is that it's very simple to get used to our variometers. But anyway, it is not my aim to make a commercial for our variometers. I'm just showing how the development of variometers went in the past to now. So that was all about the vario calculation. So obviously the variometer is not the one and only part of the gliding equipment. So I'm showing here our flag instrument, LX 9000, which is combined with that variometer and gives you all the necessary information about flying. I'm not going into details of the presentation of the LX 9000. You can ask me at the booth about that, but I will just show some, just some points what we are doing in development of LX 9000. So having this inertial platform, it helps us a lot in order to make a better wind calculation. I often receive a feedback on such meetings. Pilots would really like to know what is the wind that moment, that second. So when I'm flying, am I having a wind from 32 degrees or 33 degrees? And is it 2.7 meter per second or 2.8 meter per second wind? So as a sailman, I have to answer you, yes, of course, we calculated with 0.01 meter accuracy. But as I'm also a glider pilot, I tell you all the other truth. So using HRS, magnetic compass, airspeed indicator, it is possible to calculate, and the GPS, of course, it is possible to calculate the wind very accurately. But in order to do that, you have to have a very precise airspeed and very precise heading, the compass heading. So even if you are going to purchase, or if you are having our system and you are going to install magnetometer inside, you have to do a very precise calibration of all the equipment. Just if you are going to have a precise calibrated magnetometer and speed indicator, then you will be able to get accurate wind. Okay, the next things which we are working strongly on, it is so-called synthetic vision. So we saw that in general aviation or ultralight aviation, all the development went towards the synthetic vision. So everybody are flying with synthetic vision, and I thought, okay, we have to try to see if synthetic vision also brings some advantages for a glider pilots. So when you look on just on synthetic vision itself, I said to myself, well, it makes no sense, because glider pilots are flying most of the time in VFR conditions, so it's really make no sense to show them the hills which you can see in front of you. And we said, let's search for other benefits of synthetic vision. So we also plot the other pilot FLARM data on a synthetic vision, and that's here, and that's the only advantage I see of the synthetic vision. So you can visualize the thermals. You see how the thermals are inclined when you are climbing up, but of course you have to have sufficient FLARM data. And it was not the goal. And the next thing, what we did is that we looked for the airspace representation in 3 dimensions. Nowadays, airspace is getting more and more complex, and it is very difficult to visualize, especially if you are flying under unknown terrain, how the airspace looks like. But again, it was a very tough job, and I'm a little bit skeptical that we will publish that synthetic view into the release version at all, because it doesn't reduces the pilot workload. I would say it just increased the pilot workload, and the main motto of our company is to reduce pilot workload to the minimum. Okay, so now let's look at the cockpit panel as it is now. So this is a typical cockpit panel. You have a mechanical airspeed indicator, 9000 system, pneumatic variometer, altitude indicator, compass, let's say engine control and radio, and variometer. So obviously all these instruments has to be smaller instruments, so we are running a little bit out of the place. And when we introduced LX9000 to the market, I showed it to Bigo from Segelflyget, and he had quite a lot of problems to put the 9000 into the particular, at that time, into the Arcos glider. They have to redesign the front panel of the Arcos. They did that, but he said to me, Razem, if you are going to make a single millimeter bigger instrument, I will kill you with my we were quiet and we didn't, I obeyed his instruction. Actually, he is a quite tall guy, so a German guy, you never know what will happen. So we did make a bigger instrument, but anyway, we saw some way, and so we designed, let's say, a 7-inch instrument. I mean, people really always say to bigger is better. So let's say this is a type of the more modern cockpit. So you have a 7-inch instrument together with 80mm indicator. We have to get rid of the compass and mechanical variometer, but there are potential for further integration. For example, together with Yonkers company, this is the control unit for the jet engine from JS1. Together with Yonkers, we were able to integrate the JDU together with the LX9000. So basically, all you have to do to have now is just a switch to run on the engine, and the rest will be done by the computer itself. For example, for jet engine, it is very important that it's not like ordinary turbo, where you just switch it on, set the speed to the blue triangle 90 kph, climb, and when you reach the maximum altitude, switch off, glide, and so on. So we have on our variometer, once you are running on the engine, our vario indicator, so actually the speed to fly, is always guiding you and giving you the right speed. And the rest is everything done automatically. So the main instrument will take care of what the right RPM are, and this will maximize the speed, the range. So the next things where we are working on is integration with the radio. It is possible now that all the frequency settings are done through the LX9000 or our instruments, which is also again in the way we are doing so in order to reduce the pilot workload. So all these most likely will allow us to do so-called glass cockpit. So we would like to get rid all of the instruments and just have one big screen inside where you will have all the data presented. Why this is so important? It is not that people would like to have a bigger screen just in order to have bigger letters, because with years our site is getting worse and worse, but it is benefit of having everything on a single instrument, because then the instrument can give you at the right time the right information, and this is very important when we try to reduce the pilot workload. So this is where the state of the art of development is right now. If we go to the more distant future, maybe our cockpit is going to get even smaller. So maybe we are going to get only basic instrumentation, and on a panel, so on the windscreen, we are going to make a projected head-up display. We are already making first steps towards that. It is very good. You can easily add the other FLAR objects, so this would reduce the pilot work even more. So this is maybe one way, or it might happen that actually these are not going to be instruments at all. Maybe you're going just to wear glasses where you're going to see that. Also, Google is going that direction, but it is still way to go. But I would say this is the future where we are going. So that's it. Thanks for your attention. So if you have any question, please do not hesitate to ask. Yes. Yeah, please go.
Which innovation made innovations you have made in your company?
Yes.
You have Komputtrar, which made biggest innovation you have done in the company.
It is definitely one big step from the old way of thinking was the new variometer with integration of all the sensors. But other things, it is not really something what is breakthrough. So it is more or less continuous development. Definitely, the big step was going from small screen to the big screen. It was so to bigger, to 5.6-inch screen like Alex 9000, which gives a possibility to put much more information or valuable information at the same time to your screen. So I don't know if I answer your question.
I'm a competition pilot, competition GPS.
Uh-huh.
Sit in the championships.
Uh-huh.
And I know all the people who are flying.
Yeah.
And we have blind practice. We have the blind practice in our team last year. And he looked in the cockpit and said, "Oh, you have sophisticated instruments, but I have a L1, and I will beat you all."
Mm-hmm. Yeah, well.
So how much does it make to fly faster, and you other functions you need to have area task, very complicated task.
Do
you have some specific features in your innovation?
Yeah, it is. I didn't go into details how we are helping, for example, competition pilots, but we do have inside a very complex calculation of estimated time of arrival, which is very important for the competition pilots. So we also have some sort of statistical models which help us to predict the time when you are going to arrive back home faster. We have a very complex final glide calculation, taking into account the wind profile, taking into account the side wind. So it is plenty of small things which makes our system better. But regardless the system, I would say that at the end, always the pilot that catches better lift will win. And this is still work which pilots have to do, and I'm glad that it is like that way, because overall it is not a competition of computers, but competition of pilots. What I didn't, I will just now point it out because you mentioned the competition. We have a very good cooperation with Navitaire, and what we are trying to do is once more minimize the workload on a pilot. So we have an internet connection on our instrument to the wireless network, And my goal is I also design CO scoring, so the program that is doing scoring for competitions, and is probably one of the most used scoring. And my idea is that I would like to have a competition where there is no need to handle the RGC files, no task sheet, nothing like that. So we have now a project going on that the soaring spot or CO competition will be able to automatically send the task to the instrument. So when the pilot came to the grid, he would just see a message, "Hello, we have a new task for today, would you like to take it over?" You just press OK, you have it. And once you land, your IGC file is going to be automatically transferred to the scoring office. So there is no need, no interferences with device anymore. And if I can go even further, you will get a message on a display immediately. Congratulations, you are placed on the first place today, or something like that.
And we also can blame the competition leader of it, because if we make any mistakes,
yeah,
it should be okay.
So this is regarding the competition.
With the system that you're talking about, then we don't need to see the director or store. We can go to lunch or dinner, and we can sit there, after dinner.
But indeed, that changed a lot. For example, in the past, the people in scoring office, they have to work all the night in order to take a look at the films to see if the sectors were turned right. And now they just upload the files. They say, "Okay, results are here. Let's go for a beer." So it changed a lot. Anyway, you have one question, yes, please.
Do you have any plans to get the instruments approved as flight material? As a Form 1?
We are also working. Oops. We are also working in that direction, but it is a lot of work, and I don't think that customers would really like that we are making a certified instrument, because if I go to the general aviation market or ultralight market, you can buy a Garmin for $2,000 US uncertified. But if you want to have a certified Garmin with same functionality or a little bit less functionality, you will pay $20,000. And that's the biggest problem. Now, for example, when we are doing, we have a cooperation with JS1, and we are designing this just small unit for the jet engine. It is, you won't imagine how complicated it is to talk to us, and they are very strict. So we are working in that direction, but it's a long way to go. Robert, you had a question now?
No, that was, I was asking about the internet connection.
Ah, okay. Yeah. Well, that's it. If you, I don't know, if you have any further question, please ask.
Is your instruments is usually always working, or do you have some kind of plans of integrating a backup system from the beginning? Because most of us use
we try to make our system always work because it would be not really good from marketing point that we sell, for example, we sell an LX9000 and additionally to that also 2 nano flight recorders just in case if it breaks during the flight. So when I'm going to the competition, I'm always flying just with a single instrument, so no backup, nothing. And in our company, there are 20 people working, out of that maybe 15 people in development. and I'm pretty sure that we spent half of time just to make systems stable. So not adding any new functionality, but just to make that the system is running very stable. There are a lot of internal redundancy inside the device, so that as soon as something goes wrong, it will reboot and restart again. We have inside also so-called safe mode, so if everything goes wrong, it will go into the safe mode, and it will help pilot to get back home and to have the logger valid. I would say that the biggest problem is not the hardware itself, but are usually batteries. I'm very surprised when, for example, we receive a feedback from customers. Oh, my instrument is giving me a warning after 3 hours that there is a low battery. You are draining way too much batteries. And then when we check such installation, we see that actually it's not a problem in battery itself or in instrument itself, but is the wiring between the battery and the instrument. The contacts are loose, or the contacts are very thin and making a lot of voltage drop. So it is really, people are buying very expensive things, but they don't pay attention to the wiring itself. But we are also, for example, LX9000 is having, inside you can connect simultaneously 2 batteries to it. So in case that one will fall off, it will automatically switch on the other battery. We are also having a special so-called battery manager, because I always found the problem on a panel where you have this switch, battery 1, 2, 3, 4, and when you are switching, the instrument switches off and so on. So what we design is a small device, so-called battery manager. You just connect up to 4 different sources, and then this battery manager decided you have a priority, you have a battery 1, 2, 3, 4 to use, but then the battery manager decided which battery he's going to use first and so on. Because especially with lead batteries, the problem is not so difficult. You can discharge them all the way down. But if you are going to discharge the modern battery, like this LiFePO or even LiPo battery, which I do not recommend to use in a glider, if you are going to discharge it too much, then you will damage the battery. So therefore we designed this battery manager in order to. Okay.
In the manual of the LX8000,
Yes.
it says that you must turn off the program before you turn off the electricity.
Exactly. It is, so the whole instrument is actually a small computer. Inside, the whole Linux system is running, and it is like you are switching off your computer always with a switch off button. We recommend to switch off the LX8000 or 9000 with the off button. Personally, I always cut the power off, but I have to do that also for testing purposes. And all developers in our team, they also have instruction that they never have to switch off the instrument in a nice way. It is very low probability that something will go wrong if you just cut off the power. But maybe 1 to 10,000 cases, the computer might be in state that something is being written to the disk, and this could just damage the data. So therefore we recommend just to push the button and switch off. But if for some reason unintentionally you switch off the instrument with master switch, you don't need to send it to service to us. It is most likely nothing will happen.
But it should be possible to So 6 is the battery is off, then you would have a small backup, and then you could have a session to close the software.
Indeed, when we designed LX 8000, we foreseen, therefore also the LX 8000 at the beginning was maybe 1.5 centimeter deeper than it can be. We designed it that way that we intend to put inside the small batteries, exactly for that case what you said. But then we realized that having batteries inside the instrument will cause just more problems than without them. So at the end we decided we are not going to use internal batteries. You can just switch it off. Well, thank you very much once more.